everyone and welcome back to NotesNaka. Today is the last day of the May lead coding challenge, which is day 31, and the problem for today is edit distance. So in this problem what we do is we are given two words or strings and we have to convert the first string into the second one using these three operations, that is insert, delete or replace a character, and we have to do this in minimum number of operations. So we have to find out the number of operations that we took to convert it. So this is a very classic problem in dynamic programming, and let's check out the algorithm behind it first and then we will get back to the code.
In today's problem, we will be given two strings and we have to convert this string into this string. Now, we can use three operations to do this. We can either insert a character, delete a character, or replace a character. So basically using these three operations, we have to convert this into this, and we have to do it by using minimum number of operations. So that is the problem today. For this problem, we can see if we replace I with E, so I is replaced with E, then N is replaced with X, I guess. Yes, so N is replaced with X, and then T, we remove T so that we can get E. So we have EXE, and then we have N. So we replace C with N. So we have N. Then U. So we insert U. So we have U, and then T, T-I-O-N is the same. So we have this in how many? We have 5 number of operations we did. We did 1 for this, 2, and then we did 3 for this, and then 4, and we inserted 1, 5. So we have 5 operations to change this into this. Now to do this question, since we have to find out the minimum number of operations, we will be using dynamic programming. So for using dynamic programming, we will make a table like this, where first one will be 0 and first row and column will be 0. So we will put on this the one which we are trying to convert this side, and to which we are converting this side. So we have I, N, T, E, N, T, I, O, N. This. And this side we will keep execution. E, X, E, C, U, T, I, O, N. Now the way we will fill this is first for 0. So let's see how this works. If we have 0 characters and we have 0 characters, we do not have to do anything. So we just put 0. We have 0 characters and I. So we want to change I into 0. So there is one operation that we have to do. So 1. We have N and we want to change it into 0. So we have IN, that means IN is there and we want to change it to 0. So we will need 2 operations. Similarly, this 3, 4, 5, 6, 7, 8 and 9. Similarly, in this order also, we have E over here and we have 0. So there is 0 things and we want to change it into E. So we will need 1 operation. Similarly, this will also be filled. 5, 6, 7, 8 and 9. Now comes the main part. This was all base cases. So we have to take care of this and then we will start the main thing. Now what happens, we have E and I. If both of these are matching, then obviously we will not do anything and we will just copy the diagonally up element, and that will be our minimum number of operations. But here, since these are different, we have to do something to convert I into E. So the minimum number of operations that will be required is minimum of this, this and this. Whatever is the minimum plus 1. So minimum over here is 0 plus 1, so we have 1. In one operation we can change I into E. For N we will see now. E and N. So what is the minimum number that we have IN and we want to change it into E. So what is the minimum number of ways we can do it? I mean minimum number of operations. So we will take the minimum of this, this and this. And what is the minimum? The minimum is 1 and we will add 1 to it. So in 2 ways we can change it. Again E and T, then we will take minimum 2 plus 1, 3. E and E. Now since E and E are same, we will take the diagonally up element and we will not do anything to it, just copy. So 3. E and N, minimum 3 plus 1, 4. E and T, minimum is 4 plus 1, 5. E and I, minimum is 5 plus 1, 6. E and O, 6 plus 1, 7. And E and N, 7 plus 1, 8. Then we have X. X and I, so they are not matching, so we will take the minimum of these. So minimum is 1 plus 1 is 2. X and N is not matching. 1 plus 1 is 2. And X and T, 2 plus 1 is 3. X and E, 3 plus 1 is 4. X and N, 3 plus 1 is 4. X and T, 4 plus 1 is 5. X and I, 5 plus 1 is 6. X and O, 6 plus 1 is 7. X and N, 7 plus 1 is 8. Now we have E. So for E, what we will do is we have this and this. Minimum is 2 plus 1 is 3. E and N, minimum plus 2 plus 1 is 3. 2 plus 1 is 3. E and E is same, so we just copy. E and N, 3 plus 1 is 4. E and T, 4 plus 1, 5. E and I, 5 plus 1, 6. E and 0, 6 plus 1, 7. E and N, 7 plus 1, 8. C and I, they are again not same, so 3 plus 1, 4. C and N. C and I, C and N. 3 plus 1, 4. C and T, 3 plus 1, 4. C and E, 3 plus 1, 4. C and N, 3 plus 1, 4. C and T, 4 plus 1, 5. C and I, 5 plus 1, 6. C and 0, 6 plus 1, 7. And C and N, 7 plus 1, 8. For this one, we have U and I, again not same, so 4 plus 1 will be 5. So I completed the entire table. You can see, I hope I have not done any type of mistake. And at the end, this is the chamber that we want to return. This is the minimum number of operations, which is 5. So we return this. And our answer was also 5. So this is our answer, and this is how we solve this question. I hope this was a clear enough explanation. Now let's check out the code.
I hope you understood the algorithm. So this is the code, and if you did understand the algorithm, writing this code is no rocket science. So basically I made an array of m plus 1, n plus 1 because we were including 0. So we need one extra space to accommodate. And then these are the base cases that we discussed about the row and column, first row and first column. And after that, I ran a loop in the entire table. And if the characters were matching with each other, then dp of ij becomes dp of I minus 1, j minus 1, which is the diagonally up element. We do not do anything, no changes, if the words are same, I mean the characters are same. And if they are not same, then we find out the minimum between the three boxes, the up neighbors of the three boxes, and we add 1 to it. So that is what we did over here. And at the end, we just return the last box that we have, the last container that contains our final answer. So we just return that, and this gives us the minimum number of operations that is required. So if I run the code, you can see it has been accepted, by the way. So 3, 3, so it is the same answer. So our algorithm is working perfectly fine. And this was the last question, guys. I hope you enjoyed. I hope you enjoyed the entire journey of 31 days with us. And if you did, then please subscribe to our channel and also share it with all your friends who might be interested in content like these. And if you do like our content and everything, if you have any kind of request or anything, then please leave it down in the comment section. It really motivates us to keep doing better and making better content for you guys. And if you are someone who is interested in these types of content, then subscribe to our channel and do stick around, because we have really awesome content coming up in future, and I hope you will enjoy those too. And thank you for watching our video, and give us a thumbs up, also subscribe to our channel and stick around on our channel. We will be uploading very frequently, and we will see you then. Till then, take care and bye bye.